Hello, this is Professor Dan Kernler again of Elgin Community College. This video is part of my statistics series, and in this video we're going to do our first statistics. We're going to start learning about different kinds of tables that we can make. Let's get to it. So we're going to talk about 4 different kinds of tables, 2 that are more common and then a couple 2 less common. And those are simple frequency tables, and then we'll have relative frequency tables. We'll define what that means. And then cumulative versions of both of those where you add them up as we go. Let's start by diving into what this looks like in StatCrunch, which is the software that we are going to use for this class. For this first example, we're going to look at this Health Behaviors in School-Age Children database. I will put the link in the description if you want to practice this. You do have to have a StatCrunch account, which I believe costs about $10 for a 6-month access. So to do this, tables are pretty straightforward. We're going to go into the Stat menu, Tables, and then Frequency. There are a lot of options once you get into this menu. We actually just want the frequency. So we're going to click that, hit compute, and then we get our table. Next, I want to talk about relative frequency. Now, you might have noticed that was an option in there. You can certainly have StatCrunch do it for you, but it's really important to know what it's doing. So we're going to add another column here called relative frequency, and that's basically just the proportion of the total. So for this first item here, it's 0.018 of students are American Indian or Alaska Native. That's 222 out of the total 12,089. We can do that for the rest of them. We're just taking the count over the total. And that's relative frequency. Now, a note on rounding. We typically round to 2 or 3 decimal places. There's no hard rule where you have to do it the same all the time. One thing that is important is that you're consistent as you go. So you'll see in each of these, I rounded to 3 decimal places to the thousandths place, and I did that for all of them. So consistency is important. Now, if we did do it in StatCrunch, we'd get this table. Now, one of the things we're going to have to be good at is we want to think about what a reader is going to want to see. They're not going to want to see 0.018363802 as that first one. No one wants to read that. So you are going to have to manually round these if you're using these for a report, for a class project, something like that. So we want to get in the habit of rounding those results and not just copying and pasting what StatCrunch gives us. One thing I do want to talk about in this database is this description here where one of the options for race or ethnicity, that's how it's described in the database, is Hispanic Latinx. What do those actually mean? Now the other categories, the American Indian or Alaska Native, Black or African American, these are commonly understood as racial descriptions. Whether, what we think about race and the foundation of race is a really important discussion. It's a very common description that's included within databases like this. But Hispanic Latinx, now this is a little bit different. So Hispanic is typically understood to be those that are Spanish speaking. So of course, people from Spain and then in Latin America, but not in Brazil because they speak Portuguese in Brazil. So that's a little odd. But what about Latino or Latinx? Those are typically Latin America, but then what about someone who speaks Spanish and is descendant of Spain? So the reason I want to talk about is some of these categories are not really well defined, and how a person identifies can really be confusing once you start adding in these categories that are ethnicity, but some of the other ones are racial categories. It's really a mess. Other researchers have done a lot of thought about this. The Pew Research Center has some of these questions about, am I Hispanic? Should I identify as Hispanic? So I immigrated to Phoenix from Mexico. Am I Hispanic? Well, if you think you are. We have the other one, parents moved to New York from Puerto Rico. Am I Hispanic? If you say so, you can see some more here. I was born in Maryland. I married an immigrant from El Salvador. Am I Hispanic? You are if you say so. So all these questions are really about the individual, which really is important when we come to as statisticians analyzing those data sets. It's really important to know the variables that you have and some of the kind of oddities to those variables before we start drawing big conclusions based on that variable. The US Census actually has a specific question that breaks down whether this person is of Hispanic, Latino, or Spanish origin. So they're lumping all of those together, and it's a no or it's a yes, and they're breaking down where that yes is from for their particular purposes. In Kane County, you can see the reporting has like white alone, black alone, and then it also has down below Hispanic or Latino percent that can overlap. If you add up these percents, they will add up to more than 100% because there are racial categories along with some of the ethnic categories. ECC's application even addresses this. They have a separate question for are you Hispanic or Latino, and then you can select all of the racial groups that apply. That's certainly different from the data set here where each individual was in there as only one. So that is a huge difference. And again, as statisticians, we need to think about that very carefully. All right, quantitative variables are very different. These are a collection of numbers. So let's do a similar analysis. Let's make a similar table. This time we're looking in our lesbian, gay, and bisexual database that we have. And one of the variables in there is the age that the individual realized their sexual orientation. So age is quantitative. So there's a range of values here, and we're going to have to try to group them somehow to make a table. So in StatCrunch, we do the same thing. We do stat, table, frequency, and let's keep the frequency and relative frequency. But when we hit compute, this time we see there's a little warning that pops up here. And it says we need to create some bins. We want to group them together. Yes, let's do that. Because we don't want whatever the youngest one is, 5, 6, 7, 8, 9, 10, all the way down to 60 something, and each one has its own row. We want to group them together. When we do that, we get something like this. There are two problems with that table that, again, you as a researcher, if you're going to use this in a report or for my class, if you're going to do it on an exam, you need to manually modify this. The first is this relative frequency. Just like before, we'll want to round those numbers, be consistent. Hundredths, thousandths place are fine. In this case, thousandths place is reasonable. It's worth noting here, if we did round to the hundredths, that last one would be 0, so we should round to the thousandths place. Now the second issue, if you look over on the right and look at those bins, you can see there's a problem here. There's some overlap. Like if you have someone who realized at age 10, where does that 10 go? Similarly, all the way down. So what StatCrunch is doing here is they're actually doing 0 up to 10, not including 10. In our database, that really means 0 to 9, but the program isn't sophisticated enough to know, is it 0 to 9? Is it 0 to 9.9? Is it 0 to 9.99? You as a statistician need to know, well, my ages here were whole numbers, so it's really 0 to 9, 10 to 19, etc. So what you need to do is manually edit those, and you get a table that looks like this. So now this table looks nice. It has the relative frequencies cleaned up, and it has that overlap removed from all of those bins. And that's something that you as the statistician, when getting your results, have to manually edit. Okay, we have two more tables, and these are cumulative tables. So if we look at frequency from 0 to 9, it's 125. Cumulative frequency just means add up to that point. Well, in this case, that's 125. The next one, though, 1,060, the cumulative means 125 plus 1,060, so that's 1,185. And then similarly, we can go down, add 192, add 52, add 14. As we go down, add 4. That's the cumulative frequency. Cumulative relative frequency is similar. We have these, and we can just add them up as we go down. You should always get 1 on the bottom right down there, because let's say, well, up to age 59, what percent or what proportion are 59 or below? All of them. That's all of them. That's 100%. So if we want to interpret this, we look at this 0.952. That means 95% of all individuals realize their sexual orientation before the age of 30. So that's the 0 to 9, 10 to 19, and the 20 to 29 all added together. All right, that is it for this video. Thank you so much for watching. If you're interested in seeing more of these, you can subscribe, hit the bell to get notified. I'll be posting these periodically. I have a whole series coming out. I also want to take a moment to especially thank the ECC Board of Trustees who approved this video as part of my sabbatical project during the spring 2021 semester. Thank you so much for watching. We'll see you at the next one.